with the effective rate interest formula, yeah, it's quite straightforward. But anyway, it says here, Robin invests 30,000 at 16% per annum compounded quarterly. So if it's 16% per annum compounded quarterly for a period of 15 years, that's the scenario. Invests 30,000, 16% per annum compounded quarterly for a period of 15 years. Then they say that convert the nominal rate of 16% per annum compounded quarterly to the equivalent effective rate annual. So this kind of situation, you don't even need to stress about it. It's just a matter of using your formula. This is not on your formula sheet though. So you have to be careful. You can just remember it, you know, it's I nominal over n plus the 1 there and then to the power of n minus 1. You see, that's how you can just, it's just nothing difficult to remember really. So in this kind of a situation, you see, they're asking for the effective rate interest.
Yeah.
But we know it is equal to 1 plus the nominal rate interest is 16%. So you see here, as mentioned, I always write the percentage symbol next to the 16, you see, because it's already 16 over 100 like this. N is always the number of times it's compounded annually. So if it's compounded quarterly, then it means n is a 4. See?
Got it. Yeah.
Yeah. And then n is also a 4 there because it's the same value. And then minus 1. Minus 1. So what does this give us in the calculator?
This should give us 16. It gives us 0 decimal 169 858 56.
Yeah, boy. Okay, perfect. And then we know that this is times by 100. It's going to give us 16.99.
Yes.
Yeah, so that's the value
Why
we
do
can
you
use.
times it with 100?
Because, okay, do you see timesing it by 100 allows us to put the percentage symbol here. You see, remember the percentage symbol means something. Yeah. Yeah, because the percentage symbol is telling you that this number is actually over 100. You see. So when the percentage symbol is not there, it means something else. You see. So if you're gonna leave it like this is fine. You can do calculations with this number, but then you cannot say 0. something percent. You see, it's going to be wrong because the percentage is not like a unit. You know, it's actually something that's doing something to the number. This is dividing the number by 100, which is why these are just the same, more or less. Yeah. So now that we have this value for B, it says now use the effective. Now use the annual effective rate, which is the value we just worked out, to calculate the future value of the investment after 15 years. So funny enough, right? You see here they spoke of future value, which is just talking about a value for A, you know, but because they said future value, it doesn't mean we have to use the F formula or something. I mean, like, this is still falling under the revision stuff, so the F formula is not even being mentioned. So for B, we know we're dealing with normal compound interest, in the sense that we just have A is equal to P 1 plus I to the power of N. Now, with this formula, the money that's invested is 30,000. So that's the money, that's the original value, 30,000. We don't know how much it's going to be worth after the 15 years. So it's 15 years, remember. And the money, remember, is compounded, what you may call quarterly. Yeah. So if it's compounded quarterly, we know it's like 15 years times 4. And then the interest rate, let's see. So with our what you call, with our interest rate, right? We know it's going to be the 16.99% over 4. You see?
Yeah.
Yeah. So let's put everything in the calculator now, or in the formula rather. Okay. Let's go to 30,000. 1 plus the interest over 4. The whole thing to the power of 15 times 4 is like 60. And then what do we have now?
Then you
What is this
have
in the calculator?
363,
363,
965,
965.
decimal, 4687.
4, 6, and then 8. So it's going to be 47 if
7.
you round it off to decimal places. Well,
Yeah.
I mean,
Oh,
you have
yeah,
to
you
double check.
rounded off.
Yeah. So let's just double check, because there's no need to be arrogant. So let us be humble and do the right thing. So we're looking for chapter 3. Chapter 3. What is this now? This is chapter 2. Chapter 3 is just down here. We did, yeah. So this was 3B, right?
Yeah.
We got
Maybe
3.
it's the percentage. Maybe it's just a normal 16 or
Oh, hold on. Yeah, put 16 here. Let's see. Is the annual effective rate to calculate the future value of the investment after 12, 15 years. Now use the annual effective rate to calculate the Yeah, just put 16 here instead of the 0.99. Let's see what that gives you.
okay.
Because
Yeah, it gives me 315588. I was just wondering, why would you use that percentage?
yeah, because the one thing that's clearly certain here is because it says now, you see here, if you look at the question nicely, it literally, if the previous question, right, says convert the nominal rate of 16% per annum compounded quarterly to the equivalent effective rate. So then they said, now use the annual effective rate. You see, so meaning that 16.99 is what we're supposed to use to calculate the future value of the investment of 15 years. You see, so
Yeah.
I mean, it's not uncommon for books to have weird answers at the back. So this one is definitely one of those.
Yeah.
Because this question, it's more direct than we could even anticipate. You see, here we wanted to calculate the effective rate, and if you check the memo here, it does have our 16.99, which is perfect.
Yeah.
And then the next question is asking us to use that specific value. You see, so this is going to give us 363,965.47.
But I would have used that one, like we did it the first time, because it just flows.
Yeah.
It's just because of the way math is set up. Usually what you do in your previous answer, you use in your next answer. So,
Yeah, definitely. So it's the safest bet.
Yeah.